Hello everyone, my name is Mukul and this is the Deep Neural Notebooks podcast. This is the ninth episode of the podcast where I talk with Shalini De Mello. Shalini is a principal research scientist and research lead at NVIDIA, where her primary research interest is in machine learning and computer vision for human computer interaction and for building smart interfaces. At NVIDIA, she has developed technologies for gaze estimation, 2D and 3D head pose estimation, hand gesture recognition, face detection, video stabilization, and GPU optimized libraries for mobile computer vision. Her research has been focused on human computer interaction in cars and has led to the development of NVIDIA's innovative DriveIX product for smart AI based automotive interfaces for future generation of cars. Shalini received her master's and PhD degrees in electrical and computer engineering from the University of Texas, Austin, and she received her bachelor's in electronics and electrical communication engineering from Punjab Engineering College. In this episode, we talk about her journey, about how she got started with computer vision and machine learning, from her bachelor's to her master's in biomedical imaging and to her PhD in human face recognition, and about how her research interests shaped over the years. We also talk about machine learning inside the car, about her vision of using machine learning and deep learning for building smart assistive interfaces for inside the cars, and about how that manifested into the DriveIX product that NVIDIA recently launched. For those of you who don't know, NVIDIA's DriveIX is an AI co-pilot of sorts. It is essentially an AI-based assistive automotive interface that not only improves the driver's safety but also improves the driving experience overall and tries to make it more intuitive and natural. Among other things, we talk about the importance of open sourcing technology, about the future of autonomous and semi-autonomous vehicles, about the joys of learning something new every day, about how you can keep track of the ever-growing amount of research, and much more. It was an absolute pleasure to talk to Shalini and learn from her research insights. I hope you like the conversation, and if you do, please press the like button or give a 5-star rating depending on the streaming platform. It helps the channel and allows these conversations to reach out to more people. Thank you. All right, we'll start. Hello, Shalini. Hi, how are you?
I'm good, thank you, Mukul. How about you?
I'm good. Yeah, exciting times. I mean, unusual times. And so the first question I usually ask my guests is, uh, how are you able to sort of keep going on with your research in times like this, wherein it is easy to get distracted? And yeah, I mean, how do you stay productive in such times? Like, has work from home affected your routine in any way?
Yes and no. So NVIDIA generally has always had a very flexible policy in terms of working from home. And so even before the pandemic, there were a lot of people who worked some of the days from home and so on. So, and I was one of them. I typically would work about 2 days a week from home, and I would go into the office 3 days for 3 days. And so, it was just a matter of changing that. And the only other difference was that on the days that I was working from home, everybody else was also working from home. So, yeah, it didn't make that much of a difference, to be honest. A lot of our work is on computers. So I already had everything set up seamlessly. Because I worked from home, I had everything set up to work remotely and accessing my systems and things like that. So it was a very easy transition, to be honest. It did increase the number of WebEx meetings. And I think that the thing that I miss is sort of the whiteboard interactions that I could have in a very spontaneous manner with coworkers and colleagues, and sort of the social interaction. But for that, I figured out some ways to get around the whiteboard issue. Like you can I found like a way to use my iPad. I use an application called Notability on iPad, and I share that on WebEx from my iPad, and I can write on it with my pencil. And so I'm able to find ways to do creative ways to find ways to interact via whiteboard. But no, for the most part, it's been pretty much the same work as usual.
Right. So apart from work being changed, what has also changed is the way the conferences are being held these days. So we had the
Right,
CVPR 2020 conference this time, and
right.
it was, I think, only one conference, one big conference happened before CVPR that also went virtual. I can't remember the name right now.
ICLR.
Yeah. So
Yeah.
it is like people are trying to figure out like what they prefer more. What is your take on the physical versus virtual conference debate, if
Yeah,
you can call it
yeah,
so?
that's a very good question. So I actually attended three virtual conferences, participated in three. So there was before that we had GTC, which is NVIDIA's GPU technology conferences, also went virtual. And I was presenting two talks at GTC, which ended up being pre-recorded talks that I gave. From so I can sort of speak to it from both perspectives, as both as a presenter as well as an attendee. I think from the presenter's perspective, uh, it's nice to have the ability to rehearse and refine your talk and your spiel multiple times before, if you have the ability to pre-record it. But at the same time, it sort of takes away some of the adrenaline and the fun of presenting live in front of an audience, and sort of having your heart rate go up just before the talk. So
Right,
you miss that action, right? And also you miss the feedback. That for me, that was the really because in a live audience you get immediate feedback. People ask you questions, you share a few business cards, and you get to know people. So all of that was really lacking. I really missed that. So I think there's pros to it in the sense that maybe as an attendee, as a presenter, you have some more time and flexibility because of the virtual format. But also at the same time, you have much less social interaction, which
right,
which is really one of the things that I really miss. I look forward to at least the one or two major conferences for me. I look forward to meeting friends and colleagues that are at other companies or organizations that I've worked in the past. Over your career, you come across and meet with a lot of peers, right? And so that's the
right.
one place that I have an opportunity to catch up with them and say hello and catch a beer or something. And so you miss that piece of it.
Right. Plus, you can get a gist of whatever is going on in the field, the top works in the top fields, and you can just come to one conference, and in those 3 or 4 days, you can get an understanding of where the different fields are going, what is the best work that is happening in each of those fields. So that is, I mean, yeah, you can have that in a virtual setting also, and that is probably one of the good things about the virtual conference is that more number of people can get access to that content. Like CVPR
Yes.
2020 has released most of the panel discussions, the workshops, and the tutorials on YouTube. So people like us who cannot attend the conference anyway, either because we don't have to work to publish there, or we cannot sort of travel to the place, we can get access to all of that sitting here, getting access to the conversations of people who are in good positions and know about their insights and the about whatever work is going on in the field. So yeah, so there are trade-offs probably.
Right. Yeah, that's interesting. That's a good point you bring up. I didn't think of it from that perspective. I think it definitely helps to have exposure for more people to be virtual. That's a really good point. And I think maybe going forward, maybe a solution is some combination of virtual and real. Perhaps maybe a good balance between the two. I also do like the fact that it causes much less pollution for the world.
Right,
I mean, there's a lot of air travel
right,
involved for just getting 1,000, 2,000 people in one spot in the world.
right,
So in that regard, no, I think your point about exposure is a very good one for sure, because it sort of helps to democratize knowledge.
right, definitely. And so yeah, probably a hybrid would be a good way to go about it. Probably live streaming the conference, wherein people who are there can give you feedback at the exact time, and other people who can just learn from the conversations, from the talks, from the presentations, and learn that way. So probably a hybrid would be a good way to go in the future.
Yeah, and that's it. Like actually, even before the virtual conferences happened this year, I think Facebook had started this move where I know for last year, for example, they live streamed a lot of the presentations on Facebook, at least for like NeurIPS was live streamed, CVPR was live streamed, some of the other ones too. But it's just that, yeah, like the conversations are not there, but just the presentations are live streamed. And then I guess the other thing is like all the poster presentations are not there too. So it's not complete.
Right.
But the fully virtual is like everything is online.
Right. So now I'd like to journey back to your roots, where you started, how you got started with computer science, with machine learning, computer vision, things like that. So I was reading that you opted for electronics and electrical communication engineering at Punjab Engineering College. Am I right?
Right.
So what were your plans then? I mean, you started with electronics, but you were sort of transitioning to computers in the coming year. So, what was the initial plan, and how did that transition take place?
So I just to clarify, I never really transitioned. So at least in my undergrad college, Punjab Engineering College, there were actually three streams. So there was electronics, there was computer science, and there was electrical. So electronics and computer science were sort of flip sides of one coin, in the sense that we had a lot of coursework that was similar. The only difference being that the electronics people focused, besides coding, they also focused more on signal processing and Fourier analysis.
Right.
And the computer science people focused more on like the mathematical and algorithmic aspects of coding, which we didn't. So they were actually very similar. So why I opted for electronics was, to be quite honest, as when I was in high school, physics was my favorite subject. And I, had I not been an engineer, I would have wanted to be a physicist. And I felt that there's pieces of electronics which are like VLSI design, which have a lot of components of physics in it. So that was sort of my motivation. And I like coding. I can do coding, but I'm not passionate about coding. I rather like sort of the physical aspects of communication and so on. I really like those, like the natural science aspects of engineering more. So that was kind of my motivation. And then through my undergrad years, I did a couple of internships, one of which, two summer internships. The first one was at IIT Delhi, where I was introduced to signal processing and image processing. And I just was hooked, immediately hooked. I loved image processing. It was like the perfect middle ground. It was grounded in theory of Fourier analysis and signal analysis. And yet it was something that I could, manipulate and see. Any changes you did, like to the changes to images and things like that, you could, it's not an abstract concept. It's right there in front of you. Right. And I was immediately hooked. Like I was like, this is perfect. And then, so I did a small project at IIT Delhi where I was introduced. So in that project, I just sort of wrote up a bunch of small image filters for all kinds of, sort of like Instagram style filters. That was my first foray into image processing.
This is back in 2000, I believe, around.
Yes, this is 2000.
Oh.
This is exactly 2000. Yeah.
Oh.
There was the head of the electrical engineering department at IIT Delhi, with whom I did my internship. He introduced me to those ideas. And then I never looked back, and that's it. I knew I wanted to do this. And then the next year, for my summer internship, I applied for the JNCSR fellowship in India. And as part of that, I was accepted, and I went to ISC Bangalore, where I interned, and I worked on eigenfaces. I implemented, that was my summer project, was to implement and extend the eigenfaces face recognition algorithm. And so that, there was no looking back after that. Then I knew that image processing and computer vision was where I wanted to go. And that's what I wanted to specialize in.
That is one good thing about computer vision, is like you mentioned, that the output is right there. You can visually see how your method performed, how the model performed, compared to other more mathematical or statistical models. working direct like with images is like that visual feedback is quite addictive. Yeah. And
Right.
yeah, that work,
Yeah.
that is even, I mean, that is even how I got interested in computer vision. And most people nowadays have an option between choosing either computer vision or more language based processing. Some people try to do both as well, but yeah, the visual feedback is much more appealing that way. So, do you remember your first computer science project that way before your internship? Probably something that you worked on during, I mean, in college, like in the first few years.
Yeah, I do actually. So I think there was so this was back in 99 to 1999. And I think we had to, there was that was Windows, and there used to be this program in Windows to draw things. I don't remember the name of that application, but we had to actually code that up. It was some kind of a drawing application. And yeah, that's what I remember as my first distinct like coding project, computer science project.
Right. And it was also related to computer graphics, I see. So
Yeah, a little bit, but
it
very
makes
basic.
complete sense now that you're
Yeah.
into the same field. Right,
Yeah.
right. So after doing your BTech, you pursued your master's and PhD at UT
Right.
Austin.
Yes.
And I was noticing that your master's was based more on the biomedical imaging side and
Right.
diagnosis. That and so,
Right.
but your PhD was into 3D human face recognition. And
Right.
so, even though both are like similar in the sense that both use computer vision and you're basically learning about the basics of computer vision, but the fields are a little different. So, could you talk about how you got interested with biomedical imaging in the first place, and then what was the thought process behind like switching a little bit, or how did that go about?
Yeah, yeah, that's a very good question. When I started out interested in biomedical engineering, I think it was more of a personal decision. I'd had family members who had, um, especially, you know, had recovered from cancer, and so, especially breast cancer, and so I saw that firsthand very closely in my family, and so it was kind of very inspired to, do something about it and research in that, and so. Um, so my first project in my master's, I worked on computer-aided diagnosis of breast cancer specifically, which is designed to create automated tools for radiologists to be able to diagnose and detect breast cancer early. So it was sort of very, personally motivated more than anything else. And I'm very glad that and it was a very gratifying, satisfying project to work in. I got to work with physicians from MD Anderson Cancer Center in Houston, and contribute meaningfully to that area. That said, however, after so I was doing a degree in the electrical engineering department within the concentration of biomedical. So at the time, UT Austin had specific concentrations within EE that you could sort of focus in during your master's. So for example, communication was one, VLSI was one, and so on.
Hmm.
But then towards the end of my master's, I did realize one thing. This was 2004, that um, in terms of being sort of um, in terms of pursuing that as a career, a long-term career, it was a very niche area.
Hmm.
And biomedical engineering companies are much fewer, and the opportunities to sort of grow your career are much more limited in that area.
Hmm.
Whereas if sort of pick a more broader computer vision area, it's I thought that would be a a better choice for my career in being able to have multiple companies and options open to pursue further. So even though that is a very important problem, biomedical engineering and sort of computer-aided diagnosis, I
Right.
do feel that it is a very niche area. And if you really want to do anything meaningful in that space, there's really like a couple of industrial players in that space. There's Siemens, there's GE, there's Philips, and they're very few, as opposed to machine learning and computer vision, which has many broad applications. And so for my PhD, I decided to sort of do this very conscious choice of change. I actually continued to work a little bit on the medical computer-aided diagnosis problems as well in my PhD. So I think I've published 2 more papers in that area, in addition to working on 3D face recognition. But I did make that very conscious pivot.
Right. And I think biomedical imaging has benefited from deep learning much more in the last decade or so, probably,
Right.
because machine learning or deep learning wasn't very prevalent back then, around the
Right.
2000s. So,
Right.
could you give me like a picture of how machine learning looked like back then? And was your master's thesis using machine learning in any sense, or was it plain computer vision algorithms?
No, it actually was. So my first year at UT Austin as a master's student, I was training neural networks, believe it or not. So my very first project in biomedical imaging was using neural networks to basically, so in mammography, which is what you use for, it's an X-ray of the breast, you actually compute like 2 views, from the top view and the side view. And then there was a problem that how do you extract information from both those views and sort of line them up. And I actually used neural networks for that very first paper that I ever wrote. So so it's a full circle. It was the first course I took in my first year of my master's in 2002. And so I think neural networks, at that time, I think the feeling was very much that neural networks had sort of sunk down to the bottom because of the black box nature. Like into the 90s, there was this feeling, right, that
Right.
neural networks are black boxes, you don't know what they're doing, et cetera, et cetera. And at that time, I think it was sort of, at least in the medical field, decision trees were considered much better, simply because you can trace their reasoning path, right, and be able to understand how they're reasoning about decision making, as opposed to neural networks. So even though they were less popular, but that's what I used at the time. And I think at that time, logistic regression, hidden Markov models, there was certainly in machine learning, there was a lot of focus around those. So for me, I think, so I took sort of courses in both the fundamentals of machine learning, as well as very fundamental courses in signal processing and image processing, right? And so I wanted to have sort of the foundations of both of those to be able to solve problems on visual data, right? Or 3D data, or spatiotemporal data. That was sort of my kind of understanding of how to go about this.
Right. So, like you said, then you switched to the more computer vision side and less of the biomedical, and into a broader computer vision stream. And the
Right.
project that you worked on was 3D human face recognition.
Right.
So, was it a choice that you made? Like, did you have multiple options and you went with face recognition, or like, and what was the key reason behind picking face recognition for that matter? And how did that go about? How did that decision pan out in the coming years?
Right. So I think it wasn't like a conscious choice. It was more based on, so my professor at the time, Al Bovik, my PhD advisor, was collaborating with a company who had a very big grant from the National Institute of Standards, NIST, for a multi-million-dollar project on 3D face recognition. And so I had worked in face recognition in my past at IISc, so it seemed like an interesting problem, and I had some background in the area. Plus, it was a different problem in that it was specifically related to 3D, and that was interesting for me because I hadn't worked with 3D data before. And so it was an interesting challenge because it involved a lot of understanding. It was more closer to graphics, and it involved a lot of understanding of differential geometry from the mathematical perspective. So that was really like that piqued my interest. And I think that was the piece of the 3D face recognition problem to this day that I feel that was very valuable to me, which was the deeper understanding of surfaces and manifolds, and the differential geometry aspect of it.
Yeah, so after your PhD, you first initially worked on video stabilization more and the graphics side of it, and then
Right.
slowly moved to NVIDIA where you were back to sort of computer vision and face recognition and pose
Right.
estimation, gesture recognition, things like that. So how did that happen? What was the trajectory of your career during that time, and how were your research interests driven during those years?
Right. Yeah. So actually, my first job out of after my PhD was at Texas Instruments. I worked there for 2 years, and there I was basically an imaging scientist. So there I was actually helping to design camera image processing pipelines. So that's basically the pipeline from the time you capture the raw frame to what shows up as saved as a JPEG. There's a lot of processing that happens. And so I worked on that. There's it's a lot of image processing. There's not as
Right.
much computer vision, and there's not as much high level analysis. So I worked on that for 2 years, and it also has components of image quality assessment and things like that. I honestly did not like that at all. I wanted to just run away from that. And the reason I didn't like it was I liked the signal processing aspect of it, but what I didn't like was the lack of metrics involved to assess quality, because image or video quality I find to be very subjective,
Right.
right? It's a subjective notion. Every individual has a different way of perceiving image quality, and there's also a cultural aspect to it. People
Right.
in certain cultures, certain aspects of images or visual data are more preferred versus others. And so I came from a world of computer vision where you have very clear metrics of accuracy and false positive rate and true positive rate, right? And it's a measurable way to it's a very quantitative way to measure progress.
Right.
If you make an algorithmic change, you know which direction you need to go in, right? And so with image quality, I was just like, you can tweak an image this way, you can tweak the pipeline this way, you can make the color saturation this way. Certain cultures like it that way, some cultures like it the other way. And so I tried it for 2 years, realized this is not for me. I don't want to be an imaging scientist. My core is computer vision. I want my metrics. Right. And so after that, so I worked at TI for 2 years, and then I left TI and I joined NVIDIA. And when I first joined NVIDIA, the computer vision research team did not exist at NVIDIA. So there was a small product team that was sort of doing R&D in computer vision, and that's what I joined. And there I worked on video stabilization. I also worked on a little bit on pedestrian detection. I worked on face detection. And my algorithm for face detection is still in NVIDIA's camera pipeline. It still exists. So if you buy an NVIDIA chip and it detects your face, so that made me really happy. Like, I remember my daughter when she first picked it up and it detected her face. I was like, yeah, this is real world impact.
Right.
Right. And so I worked on that. And so that was fun. It was really fun. It was a lot of different problems, but really at my core, I wanted to do research. And so like while I was there in that team, I was there in that team for 2 years. And during that time, NVIDIA Research actually started a computer vision team. So NVIDIA Research used to be purely like graphics and architecture. And so they started a computer vision research team, and then I switched over to that team and joined it.
And now you're leading the team, I think?
I don't. So I'm a research lead. I'm a principal research scientist and a research lead. So I lead a smaller subgroup of people within it, but I don't lead the whole team. The whole team is led by Jan Kautz. Yeah.
Right. So my next group of questions is going to be about your primary research interest, which is computer vision and machine learning to improve human computer interaction. And so your research has also led to the development of the Drive 9 AI Copilot.
Drive
I think it's called.
IX. Yeah,
Yeah, DriveIX. Sorry, I got that wrong. Yeah, so
that's fine.
DriveIX. So most people in research do not get to directly contribute to an end product. It is mostly just theory, trying to come up with better systems, better models, working on the math, trying to make sure that the learning is better, that the outputs are better. But not many people get to influence an end product directly. So you have had that, and in context of human computer interaction and computer vision, how has this experience been for you to work on something that has been realized into this very powerful system that is going to be used by a bunch of companies? So how does that feel?
It feels great. It's like a dream come true. I mean, it was the vision, like it's just, and I started the research in 2013 when I joined the group. I started this whole endeavor, and it was a dream, and it was just a vision of something that could be done. And here it is, 7 years later, we just kept showing the technology that we were developing based on our vision. So I'd like to give you some sort of history about it, which is really interesting. It's like, so when I first joined the NVIDIA research, I wanted to do research in automotive. That's what
Okay.
I decided to do. So in the space of automotive, that was an up and coming area for NVIDIA. And so then the question as an industrial researcher is, so in the industry, you're a little different than like a purely academic researcher, in the sense that, at least, and specifically at NVIDIA, even though we do fundamental research, we do want our research ideas to have an impact on NVIDIA's business ultimately. So that is part of our charter as researchers, as industrial researchers at NVIDIA. And so we tend to pick problems that are more risky and that are further out from production, maybe 5 to 7 years out from production. But ultimately, we do want them to have an impact on NVIDIA. And the sweet spot to be is in picking something that, the product teams don't even think is being conceivable. And also is an open question in the research community, right? And nobody solved it. So when I looked around, I went to a bunch of computer vision and automotive conferences, specifically automotive conferences that are based on like intelligent, using computer vision or machine learning, right? Specifically, there's a conference called Intelligent Vehicle Systems that focuses a lot on this. So I looked around and I saw that everybody was working on perception on the outside of the car. And I knew self-driving cars were coming. It was just around the corner. It was obvious. And everybody was working on perception of pedestrians, of roads, of cars and buildings and blah, blah, blah. And literally, it was like 1% of those researchers were looking at the inside of the car at all. And so I recognize that as an open niche in the research community. And obviously, if it's open in the research community, it's probably wide open in the product community. Right? Because that's how the progression is. First, starts out as research, and then it trickles down into product, right? So I identified that as being a potential area to focus on. And so my research management was supportive, and I started this endeavor. And for almost 2 years, we kept developing technology. So in those early years, I developed technology for head pose estimation, 3D head pose estimation, specifically for the GPU, running on NVIDIA GPUs. It was a research paper I published at ICCV. Then we worked on gesture recognition in the early years using deep learning. It was sort of the start of using deep learning in, I think it was 2015, 2014. We published that at Face and Gesture, and then later at CVPR. And then during those times, all we could show to was the executives at NVIDIA and the marketing teams. And so, but we kept showing it, and they kept realizing that this is very cool stuff, and they kept realizing that this is out there, nobody's doing it. And so then eventually the CEO of NVIDIA, Jensen, he formed a product team specifically dedicated to focusing on DriveIX. And it was great. And when he formed the product team, we're like, here, we have all this technology, take it. And that gave them a great footing to start with, and so we gave them our face tracking, we gave them our gaze tracking, we had gaze tracking as well that we were working on at the time, we gave them our gesture recognition. And so all of that culminated at in a demo that Jensen showed at CES in his keynote address in 2017. And so, yeah, and then since then, the product team took it over. They collected more data, they retrained the models, they made it even better. And then together with them, we kept showing it to automotive companies, to Mercedes, to Volkswagen, to BMW. And then, they kept seeing, they were always really happy. They were always like, okay, this is really cool stuff. And then eventually, yeah, they decided to adopt.
Is any of those companies using this right now?
Well, we have the DriveIX is going to be part of the partnership that we've announced. NVIDIA has announced with Mercedes.
Oh.
Yeah, so that is included.
But like, if it is not confidential, could you tell me like around when should we start seeing cars with the product in there?
Oh, I don't have visibility into that, to be honest. Yeah.
Right. So like you mentioned about how the research drove the technology in this aspect. And you also mentioned that most of the research was published, and then sort of the product team was assigned and they started working on the project, and it became this system in the end. But so I see it as a thin line between open sourcing everything and not open sourcing anything and just building on your product. Yeah, just looking at your product, probably stealing ideas from the whole world, from the research that is happening, and not sharing that with the world. So two extremes could be, one could be Apple, like who doesn't share much of the research, and one open source company that I can think of is Hugging Face. So they're open sourcing everything and nobody knows what their business model is. And so how does NVIDIA sort of strike that balance between not only driving research but also developing products that pushes technology in the end?
Yeah, so we actually, NVIDIA Research, we open source a lot of our projects. So for example, some of my latest work in Gaze and so on is all open source. So honestly, it takes a lot to take research to product. And I really don't think that by open sourcing research code, you jeopardize your ability to have a competitive edge. I really don't think it takes so much more in machine learning to get to product, right? I mean, the open source codes like that we publish in the research community are based on data sets that are research only, right? Like we can't ship a product trained with that data set, with those data sets. Like ImageNet, even ImageNet is not something that you can train on and ship a product with, right? So I really think that those are like sort of two different things. And it, like you might have tested your proof of concept on a smaller research data set, but to take it to production, it involves collecting data at a much larger scale, with and multiple rounds of training. And sometimes even the algorithm can morph quite a bit to address some of the real world challenges that are required to take something to production from where it started out in the research field, right? And so I feel that researchers should share, and I think that helps to advance humanity, and it helps for everybody to learn and understand. And then I think in parallel, the production piece of it can continue to happen for companies.
So basically both can happen and it can be a win-win situation for everyone.
I think so, yeah.
Right. So talking about the DriveIX system, could you talk about the nuts and bolts of the system? I mean, I know it's a whole package. There's a lot of things going on under the hood. There's gaze estimation, face recognition, and you can also probably track people on the road, vehicles on the road, and sort of alert the user about it. It can also turn into a chatbot which can basically help you make calls and find information from the internet and all of that stuff. So could you talk about the different machine learning systems, or classical systems that go into building such an extensive system. Yeah.
Right. Yeah. So, I mean, it has a lot of, there's a lot of deep learning involved, right? And there's almost all of these components are inbuilt in-house with data sets that we've collected and, over several years, collected, refined, and so on. And so, um, not sure quite what specifically the kind of details that you're looking for, but, several, if not every single one of these components is essentially based on deep learning, right? And it runs on the NVIDIA GPUs. It also involves, after sort of developing the algorithmic aspects of it and training it and getting to the sufficient level of quality for each component, whether that's face detection or gaze estimation or pedestrian detection, and or whether it's voice recognition, right? Each of these is its own network, and after that there's also the phase of first you get it to a decent quality without changing the algorithm. Then there's typically a phase of where you try to optimize for speed, and there we use, so NVIDIA has a tool called TensorRT, which helps you compress networks, right? So we use that. Sometimes there's also pruning involved of the networks to prune away some of the extraneous weights that are not necessary, and so on. So then it's like this phase of compressing the network. And then there's the last system phase of it as well. Now you have multiple networks, right? There's one with face detection. Then once it detects the face, then on top of that, there's another one doing landmark detection. Once you detect the landmarks, then you compute the head pose, right? And so there's a chain of networks, or there's also system issues, like you're grabbing the frame. And so there's like a lot of system engineering involved to remove a lot of those bottlenecks along the way, right? So yeah, so then from the point of view of creating an SDK, there's the option to whether to use it on NVIDIA's platform or to use it on another platform, right? But the NVIDIA, if you use it on the NVIDIA platform, then it's optimized from a system perspective end to end for that platform. So there's a lot of things that happen from just the network itself. There's a lot of engineering that happens to get it to production. And I don't know if that sort of answers your question, but in terms of like sort of the intent or the design of the DriveIX is sort of to have like a more holistic view of a situational awareness for the car of both the inside and the outside, rather than just one or the other.
Right. So, little similar question to this is, how difficult is it to get the different modules to work in synchrony with each other? Because this is probably a challenge that the whole community is facing right now, is that you have a good object detection system, you have a good navigation system, you have a good scene understanding system, you have good language skills, but you cannot just put all of that together into one autonomous agent. We are doing well in individual tasks, but it is difficult to get all of those to work together into something that is greater than the sum of its parts. So, how difficult has it been for the team at NVIDIA to try to amalgamate all of these different networks into something that is, because like one example that I can think of is when, let's say, a car is approaching from the right, the system not only needs to know your face position, your face orientation, where you're looking, also be aware of the car that's coming from the right, and to also make a decision about whether to alert the user or to not. So
Right.
I think it would be quite challenging to sort of come
Right.
to get a solution to this. So, like, could you talk about some of the challenges that you faced
Yeah.
along the way?
Yeah. So I think our strategy has been to simply provide the, so first of all, each of these components works asynchronously, in the sense that it's basically provided like as a service that you can listen to and continuously, like if you have a master, you can think of it as a master that's continuously just listening to multiple services, providing you at all times bounding boxes synchronized to a particular frame, right? So that's how we make it work. And There are some components that need to be pipelined. So for example, face detection has to come before fiducial point estimation, because what goes into the fiducial point estimator is the crop of the face, right? So there is some of those components do have sort of a sequential nature, but some of them are simply independent and parallel, and they can just be running in parallel. And that's what happens. And one master system is just continuously listening to input being received from the various detectors. Right. And then our strategy is that we provide the SDK that gives you all these various components that will tell you where the face is, what the pose is, and so on. And then it is up to the automaker or the end user to use them in however way they like, in the sense that the decision-making phase of how to use the fact that somebody is looking away from their phone or is not looking at the road, right, is up to them. Is their design decision. But we simply provide the SDK that will give you the direction in which they're looking.
So like, do you give options to the end user to, like, let's say if the person is looking right, do you give them a list of options that they can configure? Like, is it a configurable option, or do they have to program the master node themselves?
They would have to, no, so we simply just give them a gaze direction. With respect to the world coordinate system in the car, we'll give them a gaze direction and say, this is where the user is looking. It's up to you to make the decision of whether you want to alert them, or you want to cause their seat to vibrate, or whatever else, or you you have these multiple streams basically. That is our strategy, right? Because different automakers have so for example, I can tell you that a critical decision in automotive automatic braking is the distance to brake, right? And every automaker has their own way of dealing with that. There isn't a standard, right? So the difference is that, like, that distance affects your errors, your false positive rate versus your true positive rate. And where you want to be on that curve is a personal decision of every automaker, right? And so that is a curve that they decide where they want to operate on.
Right. So it's more like a platform as a service and not a software as a service, probably.
Yeah, so it's like an SDK that will give you all these vision components, and then you make a higher level decision based on the various inputs, based on where you want your metrics to be.
Right. That depends on the company, like you mentioned, how they want.
Exactly. Yeah, exactly. And I've actually, through interactions with automotive manufacturers, I've realized that they actually have a very different point on which they want to operate. So for example, some people would prefer that their car not falsely alert when there isn't a dangerous situation happening. So they want to minimize the number of false alarms, whereas others want to be more conservative, and they're okay with their car uselessly beeping a few times if it takes, if it saves more lives, right? And so, but that no system is going to be 100% right. There's going to be either that, there's going to be false positive or false negatives, and you have to make that decision of where you want to operate.
Right. Probably a trade-off between the safety and the user interface, about how you want the end user to feel. Do you want them to be more safe, or do you want the experience overall to be better?
Exactly.
Right. So if I'm getting it right, the end goal is to assist the driver to or the passengers, to allow them to probably first of all make it safe for them, and to also sort of automate or make it easier to perform some mundane tasks like calling someone or getting some information. Or like, let's say I saw this video wherein the person walks in front of the trunk and it all automatically opens, so things like that. So the making the interaction much more simpler. So but it doesn't take over the control aspect, right? Like, is that something you're thinking about? Like, let's say there's a car approaching from the right, and probably a good decision would be to move to the left. So are you thinking of extending your system to sort of also take over some of the manipulations or the control part of the vehicle, or do you just want to alert the user and always want to keep the human in the loop instead of automating the process of driving or making it semi supervised in some way?
Right. So I think so getting to full automation, there's from level 1 to level 5, there's various transitions in between of how much control the human has versus the car has, right? Um, and I think we're definitely far from level 5 as of today, but we're getting there slowly, right? And so during that transition period, I think there's various roles that a technology centered towards observing the human in a car can go, right? In a fully non-autonomous setting, which is probably more than 99% of the world is in, I envision a system that observes the humans as being very important for safety, in the sense that it, at least like in terms of automatic braking or sort of alerting them to pay more attention. A large percentage of the accidents, if you look at statistics, happen today because of user distraction or driver distraction, essentially,
90%, I
right?
think I saw in one
Yeah,
of your talks. Yeah.
yeah, yeah.
Yeah.
So I don't have the world statistics, but certainly in the US, 90% have been reported to be because of some sort of a human distraction, right? So I think in that situation, something that looks at the driver and makes sure that they're paying attention to the road is important. And the other piece of it is improving the interfaces in the car that don't cause us to look away, right? For example, gesture recognition is or even voice technology in the car, I think is very useful because it helps you to not have to touch things and look away from the road to touch a screen and find manipulate buttons and things like that.
Right.
So that's sort of designed around that. I think in the middle, there's going to be a phase where maybe cars will drive by themselves 80-90% of the time, or even 70% of the time, but there'll be times where they just can't handle, right? They hit a corner case, the long tail of the distribution that they don't know how to handle, they can't navigate, right? And that'll be the phase when they'll have to hand over control to a human. So I own a Tesla, and that's with autopilot, and that's essentially what happens. There are times when it tells me, like, have your hands on the wheel. I can't drive. So in that situation, the car has to be able to know that the human is in a situation to be able to take control. Right? They're in a state, they're not sleeping, they're alert and so on. So I think for that situation as well, it's important to have the car be able to make a meaningful decision to hand over control. And then that's sort of like level 2, level 3, right? And then as we start going towards full autonomy, what I imagine is that in that situation, when we get to the stage where we can fully let the car drive and the human is like you're on a train, right? And I think in that situation, what I imagine is that that would be more for like enhancing the experience, really, and less safety critical, hopefully, at that point, and sort of more in the way of like AR, VR, and sort of a more enhanced natural user experience of interaction.
Right. So,
And if that
like,
answers your question.
yeah, it does. It does. So, with what your team has developed at DriveIX, it seems like you're more than 50% there in terms of creating something that is semi-autonomous, if not fully autonomous. So, I don't know if you can talk about the visions of the company or your team that way, but would you be interested at some point in extrapolating what you have into something that can also, because you have the inside of the car covered now, and with the product being rolled out now, you can probably focus on the external side of it, the driving, the navigation, and all of those things. So would you be like, that would be a natural extension of your goal? So would you be interested in working on that, like if not now, then probably sometime in the near future?
Yeah, I think that's a very interesting problem. I think so. Right now, we're at a point where we can perceive a lot of things in the environment with fairly good accuracy, right? Whether that's inside or the outside. But then the question is still, beyond just perceiving pose and shape and the presence of objects, right? The fundamental question is, can we perceive intent? Can we predict intent? Can we, have a more, because as I think as humans we can, like if we look at a pedestrian, we can certainly make a guess as to they're about to walk this way or that way while we're driving, right? And so I think those are some things that are still sort of the higher level semantic understanding of themes and how people are interacting with each other, right? I think that's really interesting to me, to sort of predict. And I think that ties into just not just in an autonomous vehicle scenario, but it also is interesting from sort of an autonomous robotic scenario. If you had robotic assistants working alongside you, right? They have to have some perception and notion of predicting and understanding behavior, beyond just poses uh, and presence and just their 3D locations, right? So I think that's a very interesting challenge in computer vision. And I think related also to that question is whether so that's like a sort of a holistic situational awareness, as well as like a spatiotemporal model of how people will behave over time, right? And then there's also this other question, is that we, as we go through life, we're sort of encapsulating this prior in our head, that things are located this way, they move this certain way, and then they behave a certain way, right? And then the behavior piece of it, I think there's a lot of computer vision and analysis to be done there. But I think we'll get there. I have a feeling that by looking at enough data, we'll probably get there. But I think to me, what is also very interesting is that as humans, we actually don't just use that observation of behavior to just to predict what's going to happen next, but we also sort of use that as labels in our life to just learn things, right? We don't have ImageNet, like we don't have a million images that are labeled, right, to train our minds with. But we just continuously observe, and that's how we somehow form very strong priors. And I think that piece of it is also very interesting to me from a research perspective, is like if you could just like observe things happening in your world around you, if an AI could observe that and then start to make sense of it, right? And associate it, we categorize it, associate it, there's a certain categories being related to each other, and that gives you a lot of associative labels. And that sort of aspect of few shot learning and learning with less labels, that's very interesting to me, because like I truly think that this we can only go so far with just collecting and labeling data. We're probably going to hit the limit someday of what we can do with that sustainably. Like even if we could keep doing it, you're going to keep hitting the long tails of your distribution, right? But somehow as humans, we have the ability to make a decision even if we hit a long tail. Like I could go to a European country and drive, and I've never seen an elk, and suddenly an elk walks in the road, and I have some ability to make the decision of what I should be doing, right? And so, but the AI doesn't, right? And so that's very interesting to me to see, to go beyond just annotated data, and sort of encapsulating those priors somehow. And I think there's also, I guess I'm rambling a bit, there's also like a multimodal aspect to it, which is very interesting, which is that language is a way to describe our world, which we also see visually. Right? And so ultimately they're both there's a common denominator for both of them, which is our world. They're both descriptions of our world ultimately, right? And so so there's interesting connections there, in that maybe we can learn vision from language by aligning them in the description space, right? And that's quite interesting. Or other modalities.
It seems like the research is increasing exponentially, and there are like people who are working on, let's say, pedestrian detection, pedestrian behavior recognition, or activity recognition. And so the field is getting diverse that way. But again, probably what like someone would need to do is to create a system that can integrate all of that information, and it will
Right.
probably again come down to the product engineering aspect of it, to try to create a system that can not only product engineering, I mean there would also be the research aspect to it, to create a system that can probably learn from the different inputs from the
Right.
different systems submodules that are there, and then probably it'll again come down to integrating all of that into one thing, because the field is getting diverse and there's a lot of success that we're getting in each of the fields, but probably our integration would be the most important again.
Right. Yeah.
Yeah. Right. So another thing that reminds, I mean, that I can think of from the field getting more diverse is that more number of papers are being published each day. Um, Almost everyone I speak to, I try to ask them about how they try to be updated with the field. Some
Right.
people have research labs where their peers can share them information about, yeah, what is going on in that field. You can sort of be updated about one, two, three, four conferences and try to see. You can still not read all of the papers that they have, but you can probably stick to some papers. But after one point, it then again gets difficult to keep track of all the research that's going on. So how do you think about it? How do you try to live with the fact that probably we won't be able to read about everything that's going on in research? So yeah, what is your approach towards that?
Yeah. So I think, you're right. It's basically like drinking from a fire hose. Research papers, the onslaught of research papers in our field. But that said, what I find is that oftentimes, papers have a few central ideas, right? And a lot of it is just implementation and details and how successful they were in their idea, right? So they really just distill down to like a few intuitive ideas that help them achieve success. And so, as you read more and more papers, I end up reading a lot of papers through. So, actually, just to back up a second and say, the concrete things that help me keep abreast are that I follow Twitter very religiously, and I follow a lot of good researchers on Twitter. And when they put out paper, I get to know about them early. And these are people
Hmm.
that I know, they are well respected in the field, and I know that they
Hmm.
will have papers
Hmm.
that show advances in the field, like concrete
Hmm.
advances in the field, and they're not just, for just the sake of writing a paper.
Right.
So that's one way that I get to know information quickly, by sort of having a connection to my peers that I trust and respect in the community. The other ways that I review for a lot of computer vision and machine learning conferences. Um, that really, really helps, because as in the process of reviewing a paper, you sometimes get assigned papers that are slightly different from your field, not directly in your field, but then
Hmm.
in order to review it, you go and read at least the top papers in that field and the most influential papers in that field, and that broadens your sort of knowledge
Right.
in computer vision, right? So those two ways are like the two very concrete ways in which I 100% sink myself into, right? These two
Right.
ways. And then the other way is like when I see a good paper, there's always this inclination, all right, I'll get to it, I'll read it. And that's a bad way I've realized is like you take that 15 minutes at the end of your day, not 15 or 30 minutes. And usually that's all it takes. At least skim it,
Right.
at least skim the method section, and read the central idea, skim the results, right? And that gives you an idea for, okay, yeah, what was the main intuition that they came up with. And a
Hmm.
lot of the machine learning papers, so the machine learning papers definitely are more mathematical, more dense, and you have to read them more carefully, but a lot of the computer vision papers are more applied.
Right.
So, there'll be one central idea. Yeah, okay, we did it, we tried it, we made a network. And then you get a feel for it, So,
Right.
and as you practice and you read more and more papers, you get faster at
Right.
at finding the core idea,
Right.
right? So I do that. And then internally within NVIDIA, we have a lot of like discussion groups and paper groups. I try to participate, and they're like specific, based on specific topics like 3D vision or machine learning, or and so on.
Hmm.
And so that's a great way, because I get to know the most influential and the most important ideas in a particular field from people who
Right.
are experts in the field.
Right.
So I always take advantage of those. and try to go, because you're literally getting information from the horse's mouth, because these are people who
Right.
work in the area deeply,
Right.
right? So that, and then as much as possible, we also have a lot of invited speakers, and I'm sure at the university too, you must have a lot of invited speakers who come and give research talks. That's
Right.
also a great way to come to know a gist of a field, right? And honestly, I think that it's important to have sort of broad knowledge about what I've realized over the years. It's good to have broad, somewhat superficial knowledge about the various areas, and
Right.
sort of connect them together, and then you have obviously your own area that you're very deep into, right?
Right.
But then what is helpful is like just having an open mind and just like listening to different areas, even if you don't understand them deeply. But then
Right.
if you listen to it superficially, you'll make connections.
Right.
And when you
Right.
need to dig deeper, you know where to dig deeper,
Right.
right? So I think it's okay if you don't know every last thing about every single field in computer vision,
Right.
but just being open to having even the superficial knowledge is helpful.
Right. That way, even just reading the abstract or like pushing through till the end of the introduction also helps you get a picture of what's happening in the paper. And for most
Yeah,
papers, you don't even need to get beyond the method, because all of that is like, if it's a 12-page paper, everything after the sixth page or the fifth page would be about the experiments. And all of that is only required when you need to sort of work on that specific thing and try to make something similar.
implemented.
But
Yeah,
everything, probably even till the end of the introduction, is like a good enough summary of what's going on in the field and about what this new paper is trying to bring
right,
into.
exactly.
Right. So probably the last question would be, how do you think about your research? What do you find most fascinating or most satisfying about the work you do? And probably that could lead into some advice that you could impart to students, something that might have helped you, that's something that you might suggest to yourself 10 years back, something that you might have done a little bit differently, or something that you did which helped you exponentially. So could you share your insight on that?
Sure. There were a lot of questions there. Can we break them down one by one?
Yeah, please, please.
Yeah.
Sure.
Okay.
So first you
So
can talk about like what makes you so fascinated with your research, and what makes what helps you sleep better at night.
yeah. So I think for me, I think what I get a lot of joy is in two things. One is, so for me, there's always something new to learn. I love that. I think every day that I go to work and I read a new paper, or I hear about a new idea and that somebody is thinking in a certain different way, that is what gets me. I love that piece of research, right? Like every
Right.
day. And it doesn't have to be cutting edge research. It is, if it's something that I learned, like I grew personally by learning something new,
Right.
that gets my neurons fired, that makes me happy, right?
Right.
So just that sense of just literally very very childlike sense of discovery, you know,
Right.
is very fascinating to me, and enjoy that a lot. And so so what was your next question then?
Yeah. So any advice that you can provide to students or beginners who are starting out in the field, something that you felt was pivotal in you reaching where you are right now, something that has
Right.
helped you
Yes.
quite a lot, and something probably you would have done in some other way that might help them, like.
Right, sure. So I think some things that that have helped me are, so one thing that I think has been super helpful is, I've always asked questions. I've always like dug down into the fundamentals. It is just so important, like asking why,
Right.
and taking the time to sit down and understand the fundamental mathematical concepts behind things.
Right.
Right, that has always served me well. Another thing that has really served me well is implementing things from the ground up with your own hands. You realize there are so many details and so many things. Like even to this day, I write Python code myself. I train networks to this day myself.
Oh,
And yeah,
wow.
so I'm
I don't think
extremely
many people who are this up in research positions write code themselves. I mean, that is my image understanding of how things work, but it's great to know that experienced people like you are also digging into the code till now. And
Absolutely,
right.
absolutely. I write code every day. I train networks.
Wow.
I look at experiments, and I manage people, and so on. And I think I've always loved being hands on. Because you will always talk superficially unless you know what is really happening, unless you've done the work with your own hands, and that
Right.
requires hard work. It requires long hours, but it really serves you well to understand the fundamentals of your whatever you're researching really, really well. So I think those two things is like being curious about things, and about, and like sort of being curious about, okay, how does this work, or what does it do, and then questioning, right? Like, and just sort of why, what, where, right? Not just accepting, even if it's from a top researcher, even if it's from a top university. I think always just questioning um,
Right.
everything is helpful. And then I think some things that I would say that I could have done better is, I think perhaps research is definitely important, and doing good work is important, but at the same time, within specifically the research field, I think it's also important to maintain a PR front, in the sense of evangelizing your work, and talking about it and presenting it at the right forums, and
Right.
sort of networking with the community and being a part of the community. I think I did that I was less focused on that in my career, and I think I could have done a better job of connecting with the wider research community a little bit more. So I think that is also very important, to have those connections with your peers, and sort of being out there.
Right. So one last thing I'd like to squeeze in is you were talking about to be curious and to dig into the fundamentals and try to learn something new every day in some sense. But
Right.
what I have noticed myself and seen in people is that as the field is getting larger and larger, you see someone working in this field, you see someone working in the other
Mm.
field, and you see people working in all different fields. And
Mm.
you have yourself worked in only one field and you're just
Mm.
starting out. But you see tens or hundreds of people
Mm.
working, excelling in what they're doing. And
Right.
so that sort of brings upon this imposter syndrome,
Right.
wherein you know that you're already not able to keep up with the research in your field, and you see people doing well in multiple fields or in their individual field. So
Mm.
was that ever something that you had to tackle? Like, did it get
Mm.
overwhelming at some point of time to, like, probably this happens more in the initial days. So how did you tackle that? And
Yeah. So I think there is a distinction that I want to make, is that there are fundamental ideas in machine learning and computer science, or computer vision, right? And then there are applications. And I think what is really important is to really understand the fundamental ideas really, really well. So for example, the fact that you're able to use deep learning to do a lot of problems, or whether it's convolutional neural networks or it's RNNs, those are like your fundamentals, right?
hmm, hmm,
Those, or how to train them, or how to work with them, I think
right,
that is something really worth investing in,
right,
right? Because that's your foundation of your whole research career, right? And then those, what I find is there's a repeated pattern of kind of, so those are your hammers, right? Those are your tools,
hmm,
right? And so once you have those down really, really well, you can take those fundamentals and apply them to multiple different problems, right?
right,
And that's what ends up happening in computer vision. And
right,
what I find is that there is a lot of rehashing of fundamentals in
hmm,
different applications,
right,
right? Like, how different is estimating the shape of the body using morphable models versus estimating the shape of the face using morphable models? They're
hmm,
fundamentally the same problem applied to do different areas, right?
right,
So that's kind of what I think is really important, is to those nuggets that you pick up on, right? Like, from what are some fundamental ways that people are thinking about machine learning or
hmm,
AI,
right,
right? And then you go and dig deep in those and really try to understand those. That's my strategy.
right. Stick with the basics, and probably everything else that you'll come across will be some modification or some extension of of the basics, and so probably you can at max you need to read 2 or 3 more papers, and then you can get familiar with what's happening and
Yeah,
just hang
that's
in there, I
exactly,
think.
yeah, that's exactly my strategy. But like if you see some fundamental thing happening, like if it's few shot learning, or if it's like self-supervised learning, or there is some fundamental breakthroughs in AI is happening, those you really want to be on top of.
Right. All right. Thank you, Shalini. Thank you so much for your time. This is a great conversation. I learned lots of things, and I hope the people who are watching would also learn lots of things from your insights. And thank you for talking to me. Thank you so much.
Great, thank you, Mukul. It was really a pleasure to talk to you.
Great.
All right,
Thank you.
thank you. Bye.